is introduction that we are going to cover today, subatomic particles, discovery of electron, discovery of proton and neutrons, atomic models, drawbacks of the atomic models, quantum mechanical treatment, Bohr's model, quantum numbers, shapes of atomic orbitals, filling of atomic orbitals, and electronic configuration of atoms. Okay. So first, before going into deep about the discovery of electron, let us first study about in last chapter also I had explained to you about Dalton's atomic theory. So Dalton was a very famous scientist, and he said that atom is a particle which it is an indivisible particle. Means we cannot further divide atom into subparticles, right? And he was the first scientist to tell us something about atom, and he made this statement, and Dalton's atomic theory came into the picture in year 1805. And when he said that atom cannot be further divided into subatomic particles, this theory remained valid for around 70 to 80 years. Like, people used to think that Dalton's theory is correct and we cannot further divide atom into subatomic particles. But you must have studied in your junior classes that about electron, proton and neutron, that an atom can be further divided into electrons, protons and neutrons. So Dalton's theory failed. Still, it is famous because he was the first scientist to tell us something about atom. Right, beta? Next is see, because before that we didn't know anything about atom, right? Now, if we according to Dalton's atomic theory, Dalton told us that atom, like the atomic masses of different elements are different. But is it true? Atomic masses of different elements are different. But if I talk about nitrogen 17, it has atomic mass of 14, and carbon 6, it also has one of the isotopes of carbon also has mass 14. These are isobars which has same mass but different. But according to Dalton, he said that atomic masses of different elements are always different. So here also, in terms of isobars, his theory failed. And if we talk about isotopes also, his theory failed because he said that the atomic number will be like every element will have different atomic number. But we have like chlorine 35, chlorine 37, right? Just a minute. We have, or you can say, like we have like H1, H2, H3, hydrogen, deuterium, tritium, right? H1, H2, H3, we have Cl35, we have Cl37. So his theory failed. That is why now it became important to discover subparticles. And what were the subparticles? Subparticles were electrons, protons and neutrons. Firstly, the discovery of electron took place, then proton, and after so many years, in 19th century something, discovery of neutron took place, right? So let us first talk about the discovery of electron. Now, what happened on the era came where the cathode ray tube experiments became very famous, and that is why the discovery of electron first took place on this cathode ray tube experiment. Now, what happened is, this experiment was conducted by Michael Faraday. You must have heard about Faraday. He's a very famous scientist, and he conducted this experiment. What did he do? He took a cathode ray tube made up of glass, right? And he applied high voltage generator around 10,000 volt high voltage generator, and also he took air pressure. He had also supplied vacuum pump, and the air was at very low pressure, that is 10 to the power minus 3 mmHg. Why? Actually, he tried to generate vacuum so that there are no gaseous particles present in the tube. Now what happened was cathode, this is negatively charged electrode cathode, and this positively charged anode. Now what happens was, initially what happened, this invisible rays started moving from cathode towards anode. But how did he get to know that? Because the rays were invisible. So what he did was, he made few holes in the anode, and he put a fluorescent material made up of zinc sulfide behind it, and on striking this metal surface, they found that they found a fluorescent color light on this. Right? And this material was of ZnS, that is zinc sulfide. So this experiment actually proved that since the rays are going from negative terminal to the positive terminal, means the rays are getting attracted towards positive charge, so they must be electrons, right? So this experiment was conducted by Faraday in around 1830. This was the time when Faraday conducted this experiment, right? And he took vacuums, and he said that these cathode rays are nothing but they are electrons which are getting attracted towards the positive charge. Next is, read about the results. Yes, we'll try to find out the results. See, now we know that these cathode rays, they are negatively charged, right beta? Yes, I've told you, because they were getting attracted towards positive terminal, positive anode. They've traveled in a straight line. Yes, it was fine, but like, what did Faraday do? He actually put an opaque object in between. And what is opaque object? Opaque object is one which does not allow to pass light through it. So what happened? A shadow was obtained, and it proves that the rays, they pass in a straight line. Now they possess kinetic energy. Yes, because I told you these rays, they are made up of small particles, and they are moving, they're continuously moving. So yes, they possess some energy of motion, they possess some kinetic energy. They are made up of small particles, right? They are deflected towards positive plate in electric field. Now what happened was, Faraday, what did Faraday do? Faraday, he put a positive electrode. Suppose this is, he put a positive electrode potential, electrode plates, right? And he found that these rays, they were getting deflected towards the positive electrode, right? And next they produced phosphorescence. Yes, he was able to see the color. They produced X-rays. So these were the result of this cathode ray experiment too. Now on the basis of the same experiment, right, J.J. Thomson, he also did, after seeing Faraday's experiment, J.J. Thomson, he also performed this cathode ray experiment. You can see the exact picture in NCERT. What happened was, now he performed the experiment in presence of electric field as well as magnetic field, and this is cathode and anode. Now what happens, since see this is A, suppose A, this is B, and this is C. Now what did J.J. Thomson, he said that what happened, the magnitude of negative charge, electron, it depends on the magnitude of the charged particle. The greater the charged particle, greater will be the deflection. Second, he said mass, it also depends, the reflection depends on the mass. Suppose hydrogen atom is the lightest, so it will show maximum deflection. And third, he said, like, it also depends on the strength of electric field and magnetic field applied in the cathode ray to experiment. Now he said, if we apply only electric field, this was the this experiment was done by J.J. Thomson. He said, if we apply only electric field, then cathode ray, these rays will only occur at this. You see all the rays, they will hit the rays only at A. If we apply only magnetic field, we will observe all the rays on C. And he said, by balancing, if we balance both the electric and magnetic field, we will observe all the rays at position B. Clear, beta? So this experiment was done by J.J. Thomson. Now, on the basis of his experiment and calculations, he found that he actually tried to find out the value of mass by he actually tried to find out the value of E by m. It is E by m value, that is charge is to mass value, and it came out to be around 1.75 into 10 to the power minus 10 to the power 11 coulomb per kg. It came out 1.75 into 10 to the power 11 coulomb per kg. Clear, beta? Next, charge on electron. Now, this experiment was done by Millikan. Actually, he did an oil drop experiment, which you will study in detail in class 12th in physics, right? So you don't have to go into the deep, right? So what did he do? He tried to find out the mass of electron. See, we know the value of E by m, that is charge by mass, and we also know the mass of electron, the value of mass. Now see, what happens is, what he did was, this experiment was done by Millikan. This experiment was done by, this is actually oil drop experiment, and he tried to find out the value of mass of electron, because we already know the charge on electron, and through J.J. Thomson experiment we know the value of E by me. Value of charge is 1.6022 into 10 to the power minus 19 coulomb, right, upon E by me ratio is 1.75 into 10 to the power minus 10 to the power 11 coulomb per kg, right beta? Coulomb per kg. So the value of mass of electron is, if you solve, it will be 9.1 into 10 to the power minus 31 kg. So please remember these values. We will be using these values in the numericals. Okay. Charge on electron is 1.6022 into 10 to the power minus 19 coulomb, and mass on the electron is 9.1 into 10 to the power minus 31 kilogram. Beta, clear? Is it clear to you? Okay. Next we have, after the discovery of electron, then the discovery of proton took place, right beta? Now what happened was, for discovery of proton, again the cathode ray tube experiment was done, because I have told you at that time the cathode ray tube experiments were very, very famous. You know, like if we say, like in a human life also, BBK wines. You must have heard about BBK wines, right? When BBK wines became so famous that everybody started following it, and everybody started making channels like BBK wines, right? Suppose like if some sort of fashion, some sort of fashion is going on, you can say some sort of trend is going on, so everybody start following that trend, right? So that the same thing happened in that era. Like discovery of electron, proton, also they took cathode ray experiment. They did cathode ray experiment. Similarly, but now the difference was that earlier, during that time, the rays were coming from cathode to anode. Now this time, the rays will move from anode to cathode, and this time they have put some holes in the cathode, and we will be observing. This is ZNS again. Light this. We will be observing some light on this, right beta? So similarly, now this is positively charged and this is negatively charged. The difference is the pressure that we took this time is only 0.1 mmHg, means this time vacuum is not there, gaseous particles are present. What are present? Gaseous particles are present, right? And colored rays, this time colored rays were observed, which were moving from positive terminal towards negative terminal, right beta? Okay, so these are gaseous particles, or you can say gas particles. They were moving. Now what happened was, see, anode rays, right? The first property is the four properties of anode rays. If you study, the first is they are made up of positively charged particles. They are made up of positively charged. Like in cathode rays, they were negatively charged. So these are actually positively charged particles. And the origin, since in the discovery of electron, the cathode rays, they were themselves electrons, but here the origin is actually gaseous ions. They are not itself protons, they are gaseous ions from which we were getting protons, right beta? Because gaseous particles are also present, so they were gaseous ions from which we were getting protons. Clear? And they depend on the gas, nature of the gas. In the case of the discovery of electrons, since we have considered it to be vacuum, so they do not depend on the nature of the gas, but here they depend on the nature of the gaseous particles. Suppose we have this is anode and they are moving towards cathode. Now what happens is we have gaseous particles. Now what happens? These gaseous particles, they gets ionized. And by ionizing, they will lose electron, and themselves they will become positively charged. They will themselves become positively charged. Then they will lose one electron. Electron will move towards the positive charge, and this gaseous ion, they will move towards the negatively charged. These are nothing but these are actually anode rays. Right, beta? So don't get confused. Anode rays are not protons, they're positively charged. Right? Until this time, proton was not discovered. Only electron and proton was discovered, and they also did this experiment by considering Dalton's theory that atom is electrically neutral. If positive charge is present, then there must be negative charge. And nobody knew about this, that there were some neutrons also present in an atom. Right? Now if we talk about the charge on proton, the proton charge is 1.6 into 10 to the power minus 19 coulomb. The charges and mass of proton is actually around 1837 times the mass of electron. This means if we try to consider, like, proton is much heavier than as compared to electron, right beta? Next we have models of atom, right? After this cathode ray experiment, after observing this cathode ray experiment, some different scientists came into the picture, and they started discovering electrons, and they give their own models, right? So first model that we'll discuss today is Thomson model, that is J.J. Thomson model of atom. And he said, he actually assumed Dalton's theory to be correct, and he said that atom is something which is a spherical cloud of positive charge. Can you this? Atom is actually a spherical cloud of positive charge in which electrons are embedded into it. These blue color electrons, they are embedded into the spherical cloud of positive charge. And this Thomson, he actually compared the picture of atom. He actually compared this picture of atom to watermelon, like watermelon or pudding or kheer. Watermelon, like you all must have eaten watermelon, right? How watermelon looks like. We know that the reddish part is actually the sphere of positive charge, and the black thing is actually the electrons. They are embedded into the positively charged watermelon, right? Similarly, kheer or plum pudding, like in kheer, what happens? The milk is the positively charged sphere, and the rice and the raisins, the raisins, cashews or almonds, these are the negative charge or negatively charged electrons that are embedded into the kheer. So this is how Thomson gave his model, and he said he assumed this model because by assuming such kind of model, he said that yes, the atom is electrically neutral. But after that, after J.J. Thomson's experiment, further more scientists came into the picture who did actually did experiments on electron, on atom, and they found that J.J. Thomson's model is not true, because J.J. Thomson, like when they performed the experiment, they found that there were some drawbacks, there were some problems with the J.J. Thomson's model. So then they give their own models. Okay.